Yeah, hi guys, welcome to my channel and welcome to the present lecture. So, this channel is specially dedicated for the candidates who are preparing for the UGC NET Electronic Science. And if you are seriously preparing, then this course will be really helpful to you. And in this YouTube channel, we are going to see from past a few days, we are going to see the different types of basic topics as well as the previous year questions also. So if you are seriously preparing for the UGC NET Electronic Science examination, then follow this YouTube channel. Following means subscribe the channel and then tap the bell icon for all the notifications and share this YouTube channel link to your friends or else in your social media groups who are preparing for the UGC NET Electronic Science. Okay. So regarding this one, I am introducing one new course, that is the Intense Super 30 UGC NET Electronic Science course. So this course is going to start whenever the notification is released from the National Testing Agency. Then immediately this course will start, and it is only for the first 30 registered candidates. So just hurry up. And the 31st candidates also I'm not going to take for this course. So if the strength of the course is less, then we can able to focus more on the candidates, right? So there is a 100% money back policy is also there. That means whatever the concepts we are going to cover in this course, I mean I am going to cover in this course, if those topics are not up to a UGC net JRF cutoff score, then your money will be 100% refunded. And these are all the topics we are going to say. I mean, the things you are going to get in this course, that is like 90 plus video classes, live online course it is. So regarding the paper 1 as well as the paper 2, both the two, and the doubt clearing sessions, topic wise notes, PYQs and MCQs, unit wise test series also will be covered. The course fee is 20,000 rupees is the course fee, and you can access these classes until the UGC in December 2023 cycle examination. And coming to the myself, I'm Aswini Kumar Gadige. So your mentor, YouTuber, as well as an Academy X UGC NET educator for both electronic science as well as the general paper 1. And 14 years of teaching experience is there. So qualified the GATE and UGC NET more than twice, and a lot of candidates also cleared the assistant professor or the JRF and pursuing or completed their PhD from the Institute of National Importance College from my students, and from the IIT and IIT, I mean ISC, NIT, Central University and the State University. So cracking the exams, the my students followed my lectures and the notes and their hard work and the God's grace. So everything combined. So not only not only due to my course, so due to all these three factors. Okay. So let's quickly jump into the present session without making delay. So it is the UGC NET June 2023 question. So yesterday also we saw one of the UGC NET June 2023 question, right? So you may check down here, what current should flow through the diode D2? Consider the values given in the circuit below. So basically the diode D2 is there, and they're asking about to find out this ID2. Okay, the current flowing through the diode, that is ID2, they're asking to find out. And if I took the node here, okay, so here from the source the current I2 is coming. That means in this direction the current I2 is there, and at this node, let's take this node is A. So while after crossing this node, your I2 is dividing into the two parts, that is ID2 and I1. So if I apply the, or else let's take whatever the I2 is there, that is dividing into the two parts, that is ID2 plus I1. Correct? ID2 plus I1, it is divided into two parts. It can also be explained as a applying the KCL analysis, applying the KCL at node A. We can also tell like that. So what is the KCL analysis? Okay, how can we take it as like this means? So let's have a look here. Usually KCL analysis means, so what we are going to tell, let's take the few of the branches as like this. Okay, and it is a node means which is connecting all these branches. And let's take I1, I3, I4 and I2. As per the KCL analysis, the algebraic sum of the currents flowing through the node is equal to algebraic sum of the currents leaving the node. Okay, here what are all the currents entering the node? I1 and I3. So this algebraic sum is equal to currents leaving the node, or I2 and I3. So algebraic sum of the currents entering towards the node is equal to leaving the node. So the same concept also I applied here. You may observe the algebraic sum of the current entering the node is I2 and the leaving the nodes are, leaving the node is ID2 plus I1. And from this one, they are asking to find out the current flowing through the diode D2. So ID2 can be written as I2 minus I1. Now my task is that to find out the current flowing through the diode D2 means I need to find out the I2 as well as the I1 and subtract both these two. That's it. Very simple. Now they given the cut-in voltages of the diode as 0.7. In the previous session, we discussed about the piecewise linear approximation model of the diode. Okay, the same concept I am going to apply here, but in the piecewise linear approximation model of a diode, it is having a switch, battery with cut-in voltage and one resistance, right? But here the diode resistance is not given here. For that purpose, I am just taking the battery with 0.7 volts capacity. Why? Because they're given here. So now carefully observe how I am replacing the diode here. So first of all, it is a supply, which is the 20 volts. And here the diode came. And it is the 3.3 kilo ohms resistor that they given in the circuit in the question. And it is the 5.6 kilo ohms. So it is a 5.6 kilo ohms. And it is a 3.3 kilo ohms. Okay, in the place of diode, I did not draw anything, but now I am going to draw. So just check, guys. So I am replacing the diode with a battery type with 0.7 volts here and 0.7 volts here. Carefully observe. Diode P type is replacing with the positive terminal of the battery and diode N type is replacing with negative terminal of the battery. Here also, this diode, it is a diode P type, right? P type is replaced with the positive and N type is replaced with the negative polarity of the supply. Okay. Okay, fine. Now, by looking at this thing, you can understand that at this node, how much voltage is there? 0.7 is there, correct? At this node, 0.7 voltage is there. So now, it is the I2 current as per given in the question, and the I1 is a current flowing through the 3.3 kilo ohms. Yes or no? Okay, now let's focus on this circuit. Yesterday we discussed about the KCL, how to write the KCL equation. If some current is flowing through the one resistor, then that current expression can be taken as a starting voltage minus ending voltage divided by resistance. If you're not aware about this sentence, whatever I told, then watch the yesterday's video. You will come to know. Okay. Now I2 can be taken as I2 starts actually from where? Let's take it as a ground, right? So I2 starts from here. It is flowing like this. It is flowing like this, and I2. Let's take it as a node A. So I2 ends after node A. Am I correct or not? I2 ends after node A. So from ground to node A, I2 is flowing. Now, I2 equation can be taken as a, okay, I2 equation can be taken as a, starting voltage is where? It started from ground, right? So starting voltage is 0 minus of, okay, and we're going like this. So here it is minus 20 minus of, it is plus 0.7 minus of, at node A, how much voltage is there? Plus 0.7 whole divided by, from ground to node A, okay, that is starting point of I2 and ending point of I2. How much resistance is there? 5.6K is there. So let's take 5.6. Now if I simplify this one, then what I will get? 20 minus 1.4 divided by 5.6K. So if you simplify this one, I got as a 3.32 milliamperes. If you want, you may also simplify. Okay. Now, coming to the I1. That is I1. So I1 is equal to, I'm just applying the same concept, starting voltage minus ending voltage. So I1 is starting at where? A. And it is ending at where? See, I1 is flowing like this. It is ending at ground. So For I1, starting voltage is 0.7 minus ending voltage is ground. That's why 0 volts. And how much resistance is there in this path? 3.3k is there. So 0.7 divided by 3.3k means I got as a 0.21 milliamperes. All of you understood how I calculated the I2 and I1? Okay, now I got both I2 as well as the I1. I got both these two. Now, if you want to find out the current flowing through the diode, that is D2, okay, current flowing through the diode means this one, D2. So now ID2 is equal to I2 minus I1, right? So how much I2 I got? 3.32 milliamperes minus I1 I got as 0.21 milliamperes. If I subtract both these two, then I will get 3.11 milliamperes. So finally, the current flowing through the diode D2 I got as a 3.11 milliamperes. So let's go to the question. So which option it is? Option 3 is the correct answer. 3.11 milliamperes. Okay. So in order to solve this question, what are all the ingredients you require? How to convert the, or else how to replace the diode with this 0.7 volts battery? And what about the KCL analysis? How to apply the KCL analysis? How to find out the ID2 and I1 or I2? Okay, with the help of KCL and the algebraic equations and Ohm's law. Okay, all these things you should know. So I hope that I covered uh, from the basic things in order to understand this question very well. So if you're having any queries regarding this question, then you may comment in the comment section, guys. Okay. Fine. So it is a present lecture, and tomorrow we are going to see the basic electronics series. That is, the topic is inductor. What is the inductor? Okay, and what about the inductance formula? What is the impedance of the inductor? What is the reactance of the inductor? What is the phasor diagram of the inductor? Okay, and how the inductor is reacting to the AC as well as the DC mathematically we are going to see in the tomorrow session. So what I'm trying to tell is that share this YouTube channel link to in your social media groups who are preparing for the UGC Net Electronic Science, because this channel will be really helpful. And if you are seriously wants to crack the JRF, then take the subscription of this course. That is the Intense Super 30 UGC Net Electronic Science course before crossing the 30 members. Okay, so join as early as possible. First express your interest by WhatsApp your number to the 86394 Okay, so it is a present session, guys, and tomorrow we will meet with the inductor topic. Thank you very much. Bye, guys.